Hello, AP Statistics students. We're going to be describing quantitative data with numbers. And our learning targets include calculate measures of center, like mean and median, for distribution of quantitative data, calculate and interpret measures of variability, such as the range, standard deviation, and IQR, for a distribution of quantitative data, and explain how outliers and skewness affect measures of center and variability. Let's get started. Keep in mind that we want to be able to describe quantitative data with numbers. So let's use a subject, a topic of how many colleges are you applying to so that we can collect some data. Let's go around the room and have each person report how many colleges they're planning to apply to, and then we'll put that information in number 1. So here we've got some class data. If you need to write this down, go ahead and write it down in your number 1. Then we're going to calculate the mean and the median for the set of data, and then we're going to compare them. So to start with, we know finding the mean, we're going to add all the numbers together and then divide by the number of numbers. So let's set that up. When we add together and divide by 9, because that's how many points of data we have, we get 11.1. I'm going to stick with 1 decimal place if that's okay with everybody. Next, we need to find the median. You may remember from middle school that in order to find the median, we need to put the numbers in order. So I'm going to do that first. Once we've got the numbers in order, we want to figure out what the middle number is. And I know you remember how to do this. We knock 1 down from the bottom and 1 down from the top. We keep doing that until we come to a center number. And that number is our median. Now, if we had had an even number, like 10 points of data instead of 9, we would have found the middle 2 numbers and found the average between those 2 middle numbers. But as it turns out, we have an odd number, so our median ends up being 10. Now, the other part of the question says to compare them, and they're not exactly the same, but they are pretty close. So we do talk about measures of center. These are the 2 measures of center we're going to be using all year long, mean and median. If you have some questions about how to find either one of those, let me know. We are going to find a shortcut in the calculator a little bit later, but for right now, this is how we would find the mean and median by hand. The next thing that we're asked to do is to find the range of the data, and the range, you may remember, is maximum minus minimum. So having our ordered list of data is super handy now because we can go straight there and do the subtraction of 20 minus 6, which is 14. So we have a range of 14 in this data set. Remember, range is a measure of variability. How far apart or how spread out is the data? Let's just write down a quick reminder that range is a single number, not an interval of numbers. Now let's move on. In number 4, we're taking a look at something different. It's labeled finding standard deviation, and it says, finding range is helpful, but it does not tell us how spread out the data is between the minimum and maximum. That means on the inside of those 2 extreme values. How can we find the average distance of the values from the mean? Instruction 4A says complete the table. So what we're going to do is we're going to put the numbers in, the values that we got from our data collection, into the value column. We were 1 line short, but we squeezed them in. The next thing that we're going to do is we're going to find for each one of those values the distance away from the mean. And then in the 3rd column, we're going to square the distance away from the mean. So we're going to start with the subtraction. So 9 minus 11.1 gives us negative 2.1, and then we're going to take that number, negative 2.1, we're going to square it, and we end up with 4.41, which is a positive number, just for the record. And then we're going to do the same thing for all of the values in the value column. So go ahead and fill out the table. You have your calculator handy, and then turn the video back on when your table is all filled out and you're ready to total up the numbers. So remembering that our goal was to find the average distance of the values from the mean, let's total up the distance from the mean. And that means adding the numbers that we got totaled up right here. Okay? So put those numbers into your calculator, add them up, and we end up with a total of 0.1. Okay, so then if we were going to divide that number by 9, it's going to look like we have a really, really small standard deviation, like the numbers are super jam-packed close to each other. But as it turns out, we have a low value of 6 and a high value of 20, and kind of a bunch of different values in between. So we know that that's really not an accurate measurement. Why? Because basically, the distance from the mean is either going to be positive or it's going to be negative, because every value is either going to be above the mean or below the mean. If it's above the mean, then when we subtract, we're going to get a positive number. If the original value is below the mean, we're going to get a negative number when we find the distance away from the mean. But when we add them all together, we get a number that's very close to 0. So this is not what we want. We want to really find out how spread apart those numbers are between the minimum and the maximum. So the way we deal with it is we square the distance from the mean, and then we're going to add all of those numbers together. Notice the reason that we did that is because they're all positive now. So let's add those numbers together. We end up with a total of 194.89. The total of the squared distances from the mean. So now in order to find the average, we're going to take that number and we're going to divide by 9, which is the number of values that we had in our data set to begin with. And when we do that division, we end up with 21.65. So let's go back to our instructions. It said complete the table. We did that. And then it says the average you calculated is the average of the squared distances from the mean. How can we use this to find the average distance from the mean? Find it. So what we need to do, if we have the squared distance from the mean and we want the average distance from the mean, then we need to square root that squared number. So we're going to find the square root of 21.65, and we're going to end up with, and we end up with there, 4.65. Now, just a disclaimer, I used the numbers in my calculator. I didn't trim off the additional decimal places. So if you actually square root 21.65, you may get a slightly different rounded number than I got. Anyhow, so we've done that. So we have found the average distance from the mean. Now, on our graphing calculator, let's enter, and we can do this on Staplet also, but for right now, if you have your graphing calculator, enter the classroom data, which means the original values, and you're going to follow the steps that I'm going to write down for you. So you're going to use one variable statistics under the stat button, and you're going to find the mean, median, and the standard deviation. So let's write down the steps for you. You're going to start by, when you turn your calculator on, you're going to press the stat button. Okay, here we go, stat button. And then when you press the stat button, you have some options come up. So the first one at the top says edit, then calc, then test. So we're going to start with edit because we need to put the values in. And after you press edit, you're going to have a series of lists open up. And in order to put the numbers in, you're going to type in the number like 9, and then you're going to press the enter key. And you're going to do that until all the values have been entered. So that's going to look like 9, enter, 10, enter, 20, enter, etc. And so that's going to create the list of numbers. That's going to be to input the data. We'll just put that here to input. So those are our steps to input the data. The next thing that we're going to want to do is we are going to run the one variable statistic. So again, we're going to go back to the stat key. So stat. And this time we're going to select calc, which of course means calculate. And then we're going to choose the first entry, which is called one variable statistics. That opens up, depending on which calculator you're using, an opportunity for us to indicate what list we're using. In order to indicate the list, you're going to press the second button and the number of the list. So that would be, for instance, second 1 if you put it in list number 1. The frequency list should be blank because we are not creating a frequency list with this particular entry. We will later on in the year. And then we press calculate. And that's going to give us a bunch of different stuff. One of the things that we see is what we call X bar. So the name of this is X bar. And that means mean. We're going to learn more about symbols later on, but for right now, you're going to see on your calculator X bar is equal to 11.1 repeat. So I'm just going to, again, round to 11.1 like we did before. And then we're going to come up with the sigma, which it says sigma sub x, which is the standard deviation. We'll talk, again, more about symbols, but when you make a sigma, it's kind of like you're making a zero and you forget to stop. And then that's going to give you 4.65, which matches what we found in part B of the table of 4B. So you may have noticed when you got the output on your calculator where for the one variable statistics that there is the X bar, then the sum of all the X values, then the sum of all the squared X values, then something called S sub X, S with the subscript of X. And that number was slightly higher than what we're looking at. We found a standard deviation sigma sub X of 4.65, but S sub X is slightly higher at 4.935. 936 if we round it correctly. And I just want to draw your attention to that because the difference between S and sigma in the calculator, both of those are representing standard deviations. I don't want to get too far into it right this minute, but when we're looking at a set of data that is representing the whole population, like our whole class, for example, then we would use the sigma, which is the 4.65 standard deviation. But if we were trying to figure out a number that would represent the whole senior class at our school, and our class is just a sample of that group, of that population, then we would use the S number, the 4.94. So I just wanted to draw your attention to that. Now, what does that really mean? That means that there are two different formulas for standard deviation, and they're not super different. So I'm going to try to squeeze in those two formulas right here so that you can see the difference. And the first one that I'm writing down is the standard deviation of a population. That's if our data set is the only group that we're interested in. Then we use that sigma in the calculator, and the formula is exactly what we followed in the table. The square root of the sum of the differences of each value from the mean squared, and then divided by the number of numbers that we have. The other formula is very similar, except instead of dividing by n, we divide by n minus 1. So you may want to jot those down. Again, for the most part, we're not going to be using the formula, but it is good that you know where all of the numbers come from, and that formula is on the formula sheet that you get for the exam. Okay, so let's carry on with our notes, and we're up to number 6 now. And so it says we forgot to add College Advising's best customer, applicantina. She applied to 30 colleges. Add her to the data set, calculate the new mean, median, and standard deviation. How does it compare to the original measures, and why do you think this is? So what I'm going to do to start with is I'm going to write down the original mean, median, and standard deviation from all of our original calculations that we have already done. So now that we've got those written down, let's make the assumption. Let's go ahead and replace our maximum, our previous maximum, with the new maximum of 30. So instead of having 20, you're going to type over that in your stat edit with 30. And then we're going to rerun the one variable statistics. So when we do that, we're going to have a new mean of 12.2. We're going to have a new median of 10. And I just realized that I forgot to show you where to find the median in your one variable statistic. So go back to your calculator. You overwrote the 20 with a 30. And next you're going to run the one variable statistics, stat calc one variable statistics. When you do that, you have X bar up the top and all the other things that we talked about. And then you're going to scroll downward until you see MED for median. Okay, so I just wanted to mention that. Totally forgot to tell you that before. And we're also going to have a new standard deviation. We'll use the sigma, and this time it's going to be 7.16. The question in number 6 asks us, how do these new numbers compare to the original measures? And why do we think that is? And we can see that the mean and the standard deviation both increased from the original, and the median stayed the same. Why do we think this happened? Well, we pretty much know why it happened because we just calculated all three of those values by hand in addition to figuring out how to do it in the calculator. And so we saw that that new large maximum increased the total. So when we calculate the mean, we know that we're dividing the total of the data points by the number of data points. And if the total increases, the mean is going to increase. But if you remember, when we went through the table, we calculated the standard deviation by subtracting each data point minus the mean. So if the mean changes, the standard deviation changes. The median is different. It's based on position, so it is not affected when we change the maximum value. It's not affected at all. Now, if we had added an additional value, we would have gone from having an odd number of numbers to an even number of numbers. So definitely the median would have changed slightly, but not nearly as significantly as the mean and standard deviation change. So it took us a really long time to get through this page of notes all together, and so I want to apologize for that. I definitely didn't mean for it to, but it was kind of rich in the amount of information that we were able to gather. So when we get to the next page, we're going to fill out the big ideas, and then you're going to be working on your understanding independently. And remember, we'll talk about it in class, or you can check on the posted guided notes to see the answers to that. So let's fill out our box of important information. So if you remember, our learning target number 1 was to find the measures of center, mean, and median for a data set. We find the mean by dividing the sum of all the data values by the number of the data values. And we use the mean when we have approximately symmetric data because the mean is affected by extreme values. Now, when it comes to the median, it's just the middle point of a distribution, or the mean of the two middle points. And the median can be used for both symmetric and skewed data, but it's really effective with skewed data because it isn't affected by those extreme values like the mean is. Not being affected by the extreme values is something that we call resistant. Our next learning target was about variability. And the first measure of variability that we talked about was the range, which is the maximum minus the minimum. Then we have the standard deviation, which has that ginormous formula, which thankfully will be on your formula sheet so you don't have to memorize it. Now, what does the standard deviation do for us? One of the learning target, or one of the parts of the learning target, was that we wanted to be able to interpret it. And so what we would say is that the whatever context we're looking at typically varies from the mean by the standard deviation. And so when we're talking about the number of colleges, it would be something along the lines of the number of colleges students are applying to typically varies by 4.65 from the mean of 11.1, looking at our original data set. Okay, I'm just gonna separate these a little bit, and then we've got our last learning target to talk about, and that was how outliers and skewness affect the measures of center and the measures of variability. And we were able to see through kind of working through different data sets or changing out our maximum value that the mean and the standard deviation are greatly affected by outliers. And the term that we use for mean and standard deviation are non-resistant measures. And that different measures are appropriate for different types of distribution. So when we have skewed data or we have outliers, extreme values, then we should use the median as the measure of center. When we have symmetric data, we can use the mean. Okay, you've got to check your understanding set of questions now. This should only take you about 5 minutes. Remember, if you have any difficulty, we're going to talk about it in class, but otherwise, go ahead and work on it. Check your answers in the posted notes, and I'll see you back in class.